as well. So before we begin in this course and we really start to dive in, it's important to cover one of the topics that I'm going to harp on the most, which is effective note keeping. If you're going to be successful in your career and you're going to be successful in this course, you really need to take good notes. Now, in this first video, I'm going to show you what my notebook kind of looks like, not only for my personal notebook, but as a notebook for an assessment and how I might take notes for an assessment. And then I'll also show you some note-keeping applications that I prefer or I've heard students prefer. In the second video, we're going to cover how to install one of the applications and another cool application used for taking screenshots. So let's take a look at my notebook first. So here is my notebook, and actually let's click over here. So this is my notebook, and you can see it's really long. It's got all kinds of stuff in here, and it's just something that I build upon. This one in particular is actually only geared towards Active Directory. So I have a few different notebooks. This one is Active Directory, and it's actually a few different courses that I've taken in the past that I've kind of put together. And then just for assessment work, etc., I just kind of have a little cheat sheet here. So I wanted to show you this one in particular because these were built off of courses, and you're going to be working through a course, so kind of just get an idea of how maybe to structure it. So here you can see I structured it, and I've got different modules here where, okay, module 1 might have had this email macro fundamentals, module 2 here has all these different components to them, right? And we have our notes, then we have child notes, and even sub-children to those child notes. And I'll show you how to create that here in a second. But let's say, for example, enumeration, which is one of the most important things that you're going to cover in hacking. And we take a look at enumeration. You don't have to understand what any of this means here. But you could see if I want to look at a domain and I want to get the current domain that I'm on, here's the command I run. And here is a picture of what it looks like. And here's what comes back when you run that command. That's great. That's what I want to see. And I have a whole list of commands for all of these in here, right? So if I'm confused on a assessment and I want to go and find a command that I'm not sure of, I can go to my little cheat sheet here. Now, again, this is really long, so you have to create your notes the way it really helps you. For a course, I think it's good to write it all out step by step like this, and then go back and make a cheat sheet. I don't need these pictures anymore. I've been doing this for a while. So maybe I just say, hey, get current domain is get net domain. And then I say, hey, okay, get object of another domain. Here's an example of it. I don't need the pictures because it makes it really long. But as an example, and over time, you learn with the pictures as well. At least I do. So let's build from that. Here is an example of an actual assessment that I did for a client. And you can see how I did this. Now, I did an external, internal, and web application assessment for this client, and these were the findings. Now, I'm only going to show you what is masked or obfuscated already or doesn't reveal client information, but as you can see here, one example is on the internal, they had something called SMB signing disabled. You don't need to worry about it, but here in my picture, I've got a nice picture. The picture has highlighted, it says, hey, message signing disabled, that signifies SMB signings disabled. And it has the IP address. So we identified the machine and we give proof of concept that this SMB signing is disabled here. Another example, MS17010. These are both internal exploits that you're going to encounter in this course. Here's one. I checked this machine. It says, hey, this target's not patched. Now this is one I didn't exploit, but it shows that it's actually vulnerable to this attack. So these are a couple screenshots that I'll put. Now, your notes could be different than mine. How I organize is I take a screenshot, I put it in here, and then I make sure that I have at least the IP address and the screenshot for reference because I'll remember it. But if you need to go in here and take detailed notes, that's absolutely fine as well. You always want good notes for your assessments because you never know if a client's going to come back in 6 months or even a year and say, hey, what was that one thing that you did here? And if you go back to your notes, you say, oh, I did this. And some people get down really into the weeds. They have dates, times, everything for step-by-step what they do on an assessment. And that's completely up to you and how well you take your notes. This is kind of how I lay it out. And then you see the green check marks next to it. I add those green check marks when I'm doing my report. So as I'm building my report out, and I cover something in the report, I'll just go ahead and right click and I'll change the note icon to a check mark, meaning that I've written that part of the report for that finding. And we just kind of go through over time. So with that being said, I do want to show you some decent applications. The one that I'm using here and that you see is called KeepNote. Now I run on Windows as a base. So keepnote.org, that's how you get KeepNote. It is for Linux, it is for Mac OS X, but this is totally a preference thing. Me, I prefer it. I've been using it for a long time. Some people don't like it, okay? So I'm going to offer some alternatives as well. Cherry Tree comes built into Kali Linux, as you're going to see here in just a little bit. Worth looking at, worth trying, seeing if you like it. OneNote's another example if you use Microsoft. And if you're a Mac user, a lot of students have told me that Joplin is really good. Now, I've never used this, but I keep hearing great things about it. So what I'm going to do is I'm going to put all of these into the course resources, and you'll be able to look at them, download them, decide on your own. Now, you're not limited to these 4 note-keeping applications by any means. Feel free to use whatever you like to take notes. If you want pen and paper, that's great as well. So just make sure that you're taking good notes, and we're gonna harp on this throughout the entire course over and over and over again. So make sure you're taking good notes. So from here, what we're gonna do is we're going to install KeepNote in the next video, and we're gonna install an awesome tool called Greenshot. And I'm gonna show you what Greenshot does and why it's so cool, and I cannot live on any assessment without it. So let's catch you over in the next video when we work on installing those tools. All right, so in that example in the last video, we talked about using KeepNote. So if you go to Google and you type in KeepNote, all you gotta do is come here, and KeepNote works on Windows, Linux, and Mac OS X. So great tool. The only issue with this tool is it has not been updated in a long time. Some people find issue with that. If you're one of those people, I'm actually not, you can use other tools. OneNote is an option. Cherry Tree is also an option. You can also find other options out there for you. If you have a favorite note-taking tool already, that's absolutely fine as well. Just make sure to take good notes, especially during this course, and make the most of it. Learn all the things that you can and incorporate that. So I will show you quickly how to install KeepNote here. And another thing to note too is while we do this is Cherry Tree is available on Kali Linux. We're going to install Kali Linux here very soon. So once we install Kali Linux and we get into the introductory Linux and we explore it, I'll show you a little bit more of Cherry Tree and what that looks like. And we'll talk pros and cons of Cherry Tree when we get there. So here we go. If you are on Windows, you can follow along, or you download your appropriate one here, depending if you're on Linux or if you need Mac as well. So I'm going to go ahead and install the exe, and I'm just going to actually run this. We're just going to say yes, and I'm going to say next, install. And that's it. I mean, it's that quick. And then we just launch KeepNote, and here you go. We've got KeepNote. So the other tool, the really cool tool that I love, this one is called Greenshot. Now this is a screenshot capturing tool. So let's go to downloads here on Greenshot. If you are running on something other than Windows, or Windows or Mac, so basically Linux, you're going to need a different tool. The recommended tool that I have heard out there is called FlameShot, Flame. Though I have no experience with it, I've heard it is identical to Greenshot. So here I'm going to download the latest stable. I'm going to select run. Yes. Okay. Accept the agreement. Give away our firstborn. Next. Place it however you want. I'm just going to next through everything, and I'm going to start Greenshot with Windows Start. That is my preference. I love this tool again. So it's finished. All right, let's take a look at it. So it should be running. Let's start Greenshot now. Okay, now you see it running down here on the bottom. Okay, let's go. Let's open up a web page. Let's say we want to take a screenshot of something. Now you just hit your print screen button, and this nice cursor gets brought up here. And let's say we want to just take this downloads part right here. We're just going to capture this. And now we have choices. We can just save the image that we just grabbed. Or my favorite is that we can actually just open in an image editor, right? So let's open this in their image editor. Look at this. Okay, so here's the picture we just grabbed, right? On top of this, really great tools. Let me show you two that I use always. So I come into effects, I put a border on it. Let's say that you have like a Kali Linux, and Kali Linux, if you've never used it, has a black terminal. It's really nasty. So let's imagine here that it's black. It's nasty when it comes to reporting. So let's imagine that we're in this situation and we're writing a report and we've got this black background similar to this. Well, you can see what I just did. I just inverted it. And I do this for all of my reports. I invert the Kali background. So that way it's white. And that way it looks nice on a report. And when we get into the reporting, you'll kind of see what that looks like. But I like a nice clean background. It saves on ink as well if they were to print it. And it's just nice and neat when you give it to a client. So I always invert my images if I need to. You've got the black border here. Another thing is, let's say you want to point something out. You saw in my Keep Note notebook that I had a highlight. You can just click that button up here and just highlight something, like right here. Great. Another tool that's in here is this obfuscate. So let's say that there's like a password or something really sensitive in here that you don't want the client to see, or you don't want to reveal in a final report. You can do that, and then you can just like up the pixel size on this and make it really blurry, you know? So it's a really, really great tool. And then when you're done, you can copy it to your clipboard, you can save the file. I just usually like copy this, and if I want to go paste it, like, you know, make a new notebook or whatever, I'll just paste it in my Keep Note and just kind of go from there. So again, fantastic tool. Awesome to use. If I had two recommendations for your note keeping, it's Keep Note and Greenshot. If I had to make one recommendation out of the two, it's absolutely Greenshot. You can be flexible on your note keeping tool. So again, hopefully this helps you. Again, please do take good notes through this course. You're going to find yourself wanting to know, hey, what was that command I ran again? And because we're going to go through so much stuff by the time this is all said and done that you're going to want to remember it. So please take good notes. So from here, let's go ahead and move on into our networking refresher, and we'll catch you in the next video. Hello everyone, and welcome to this section on networking. So this section is titled Networking Refresher, meaning that some of you might have a networking background. And if you're looking at this list that's on the screen and you go down the list and you say, yep, I know all those, you can feel free to skip this section. If you've taken some of these in the past and you just might want a little bit of a refresher on them, then this section is for you. We're going to cover these topics not totally in depth, but we're going to use it as a way to brush up. And then we'll hit on networking again when we get into introductory Linux. So if you are unfamiliar with things like TCP, UDP, and the three-way handshake, or if your subnetting's a little shaky or you don't know what the OSI model is, chances are you should probably stick around and just click through this series, watch it, and build that foundation. Remember, we talked about one of the core foundations of pen testing being a strong networking background. This is a good way to build it up, remember what you might have forgotten, and go from there. So let's go ahead and just jump right into the first video, which is going to be IP addresses. What's up, everybody? So I'm going to preface this video really quick with that it is raining pretty hard here. So if the soothing sounds of the rain put you to sleep during this video and you can hear it, I'm very, very sorry. But the show must go on. So what we're going to be doing today is we're going to be talking about IP addresses. Now, if you've ever used a computer before and you're anywhat familiar with IT, you probably know what an IP address is. But I want to take this a little bit deeper in theory on why we use IP addresses, what types of IP addresses are out there, and talk more about protocols and how IP addresses are actually designed and made up. So I'm here in a Kali terminal, and I'm just going to type in a simple command, and that command is ifconfig. Now, if you've used Linux before, this might be familiar to you. If you used Windows, it's similar to ipconfig. All I'm trying to do is bring up my IP address. So what we can see here is that we have an IP address, which is our inet. This is my IP address here. I also have another IP address, this inet6. This is what's called an IPv6 address. So we've got this inet, which is considered an IPv4, and this inet6, which is considered an IPv6. Now you can notice right away that there's two different types of notations for these. This inet here is in a decimal notation, and the IPv6 is in a hexadecimal notation. We'll get to the importance of that in just a second. So when it comes to IP addresses, this looks probably pretty familiar to us. This is an IP address. This is how we communicate. We communicate over layer 3. And you're going to hear me talking about layers repeatedly throughout the course, or at least throughout this part of the course, so that we can get familiar with how we're actually doing this. So I want you to be familiar with troubleshooting these layers, and these layers all refer to something called the OSI model. So when we talk about layers, we think about the OSI model, and I'll introduce the OSI model here in a few videos, and it should all click once I introduce the OSI model. So if I brought in the OSI model up front, it might be boring, might not make sense. So I'm going to introduce the OSI model near the end, and you're going to say, hey, yeah, that all makes sense. So what we've got here is we've got this IPv4 address, and this is the most commonly used format that we use today, right? We use IPv4 for mostly everything. And again, this is in that decimal notation. So when we see this decimal notation, it's just realistically a bunch of ones and zeros that are put together so that we have this human readable format. Realistically, all we're seeing here with 192, this first section here, this first octet, is actually just a bunch of ones and zeros. It's 8 bits. So we've got a range of 8 ones and zeros here. We've got another 8 here, and 8 here. So when it's all said and done, this INET, or this IPv4, is made up of 32 bits, 8 plus 8 plus 8 plus 8 here, and which equals 4 bytes. So another way to think about that is to think about it as, say, something like this. 1, 2, 3, 4, 5, 6, 7, 8, period. Okay, that is one section there. So we've got 8 ones that can make up this, and then we'd have another 8, etc. I'm not going to beat a dead horse here. But I do want to give you guys another example. So if we go into our applications and we go to a text editor really quick. So the way this looks is something like this. We start with a number like 128. I'm going to try to space this out as best as possible. And all I like to do is think of 128 as my base. And this will make a lot more sense when we get into subnetting. So please, if you're confused by this, don't worry. This is all theory right now. When we get into subnetting and we get hands-on, it'll make a lot more sense, I promise you. So let's say we have ones and zeros here. If we have a 1 for each of these sections, and I'm going to space this out again as best as possible, it's not pretty. But if we have a 1 for all of these, this equals 255. Why does this equal 255? Well, you take this, and all these numbers add up, 1 plus 2 plus 4 plus 8, all this adds up to 255. So let's say if we didn't have all the ones and zeros, we had just some ones enabled, like these last 3 here. Okay, well, this would equal 7, because we have 4 plus 2 plus 1 equals 7. So our first number, or whatever number this applied to in the octet, would be 7. So if we had 7.7.7.7, it would just be this numbers repeating over and over. These numbers repeating over and over, right? So be 0000111 dot 0000111 and so forth. So this is kind of what it looks like behind the scenes, because again, a computer is just ones and zeros. We're all binary. So what we're going to do is we're going to close this out. We're going to talk a little bit of other theory when it comes to this, and why INET or IPv6 and why IPv4. So let's close this and let's talk about IPv4. So I'm going to bring up a calculator. And with IPv4, we have these 32 bits. So what we can do is we could take 2 to the 32nd power. And this is the possible amount of IP addresses that we could have. So we have somewhere in the 4 billion range of IP addresses. Well, spoiler alert, we don't have only 4 billion people on Earth, right? We're up to 7 something billion at this point, and all these IP address spaces are gone. So IPv4 has been around since 1981. Nobody thought we were ever going to use all these addresses. Computers weren't really a thing. Who knew that we were going to want all these addresses? And, you know, these companies started buying them up, and they started buying them up in large chunks. And then they sold those to ISPs, and then ISPs sell those to you. And so these IP addresses have been gone for a very, very long time. And chances are when you have an IP address and you get this IPv4, you're only going to get one. If you're a corporation, you might buy more, but we've run out of IP address space. There's just not enough to go around. So the theory is, okay, let's come up with something different. Let's come up with IPv6. Now, this hexadecimal is actually in 128 bits, which makes things just a little bit longer and adds quite a bit. So let's take this 2 to the 128 power, and we get a number that I cannot tell you how to say, not even going to try. But I can guarantee you that in our lifetime, we will never use this address space. So we've come up with the solution of IPv6, but nobody really uses it. IPv6 is just a thing that's there, but when we get IPv6 addresses assigned, but still to this day, everybody's using IPv4. Well, how is that possible if we're using IPv4, but we're out of address space? Well, think about this. We're using something called NAT, which is Network Address Translation. Now, let's think about your network. So you might have a cell phone or computer or multiple devices. My network has at least 20 devices on it. I've got cameras, I've got multiple cell phones, smart TVs, everything that connects to my internet gets an IP address. And that's 20 IP addresses right there, right? So let's say I have 20 devices. That's 20 IP addresses. Am I taking up 20 IP addresses out of that 4 billion? No. We're actually using something called Network Address Translation, or it's called NAT for short. And we'll talk about this again when we set up our actual lab. But with NAT, what we're doing is we're assigning these private IP address spaces. So we've got this 192.168.57.139. Now, if you've ever seen a IP address before and you've been on a network, good chances are it probably started with 192, or maybe it started with a 10 dot or something along those lines. And that's because those are private IP addresses. So anything that starts with 192.168 is not an IP address that is going to be out in the interwebs. It is going to be an IP address that is only known to you. These are called private IP addresses. So because we use these private IP addresses, we can pass them out through what is called a public IP address. Now, to make better use of this, let's go out to Firefox, and I've already got a tab open. So I went to Google and I just said private IP addresses, and I clicked the second image here because I think it's a great image. So if we look at this, there are classes of IP addresses, private IP addresses. Now, there is a class D and E. We're not going to worry about those. The big three are class A, B, and C. If you know these, you are good to go. So if we look at class C, this is what the most common household and small business use. So we see it starts with the 192.168.0.0. So the 192.168 are constant. If you see a 192.168 address, you can guarantee yourself that that is a private IP address space. And then we have the range of changing this number between 0 and 255 and this number between 0 and 255. Why 0 to 255? Well, that'll all make sense when we get into subnetting. But what that allows us to do is have a large number of networks here and a small amount of hosts. But for a regular user like you or I, or a small business, 254 hosts is pretty good. I mean, I'm only using like 20 in my household. So the most common household is probably using this 192 address. But what about a big business, right? Something huge. Okay, well, they might use a 10 address because a 10 address frees you up to anything after this 10 is private. So 10.1, 10.1.1.1, whatever you want to put in here, up to 255 on each octet makes for a small amount of networks, but a large amount of hosts. Okay, and don't worry about the host versus network thing. Again, subnetting, we'll talk about that. It'll all make sense. But just imagine the amount of hosts that you can put in here with this wide range. So because of this, you'll see larger corporations using 10 addresses. You'll also see a lot of corporations, even small businesses, using 10 addresses. The matter of fact is, as long as you have this private IP address, you're good to communicate across your network. So any IP address outside of these and the loopback here are free game for the public address space. They're probably already owned, and you purchase those or rent those really from your ISP, your internet service provider. So going back to this thought, we have a class C address. My network's class C, 192.168.57.139 here. So it falls into that class C. I've got all these devices on this 192.168 network. All these devices are talking out of one IP address. That is my public IP address. That is what I rent from my ISP. And all of this network traffic goes out one IP. So this is how we have achieved or solved the issue of running out of address space without having to use IPv6. Not that there's anything wrong with IPv6. It's not pretty. I mean, it's way easier to type this stuff in than it would be to type something like this in. But at the same time, this is how we've solved it. We're able to still use IPv4 in mostly all networks, and we are able to communicate out with this quote unquote IP address shortage. So hopefully that makes sense. We're going to build upon these concepts. Again, IPv4, IPv6, IP addresses are layer 3 protocols. Layer 3 is a router. So when we route traffic, we route via an IP address. So we're going to build upon that as well as we go in. Hopefully this is all just a refresher to you. So that is it for this video. I'll go ahead and catch you over in the next one. All right, so we're going to move down a layer here and talk about layer 2. So remember, IPv4, IPv6, IP addresses as a whole, that is layer 3. We're talking about routing. Here in layer 2, we're going to be talking about a MAC address or a physical address. Now, MAC stands for Media Access Control, and that is identified here in our ifconfig as this ether here. So we could think of this as our physical address and a way that we communicate when we are using switches. Switches communicate over this physical address. This is kind of how they know what device is what. So what we say here is if we have a device, say you just built a computer and you're installing your network interface card or your NIC, you're going to plug that in and you're going to have a MAC address for that NIC. Your cell phone, that's going to have a MAC address. Anything that's using a network interface is going to have a MAC address. So these MAC addresses are important because they utilize layer 2 or switching, and they are how we communicate over switches. Now there's something to be noted briefly about MAC addresses. Now MAC addresses have identifiers. So as you can see here, this MAC address has 6 different pairs of 2, right? And what we can do is we could take the first 3 pairs and we can just copy this and we can go out and we can try to put it into a MAC address lookup. Now for this one, this is just going to be VMware. I'm not sure if it's